So welcome to the course Problem Solving Through Programming in C. So this is tutorial session 1. I'm Siddhant, and I'll be assisting you with your problems and queries regarding this course. So this course is it's a repeat course. It is floated on NPTEL by Professor Anupam Basu from Department of CSE at IIT Kharagpur. And probably all of you have gone through week one's lectures, and um, so I'll be just briefing over what Sir has covered over the past week. The first thing that you did when you're introduced to this topic is problem solving. So that is the most important part of this subject name. The programming in C is just a method. The main thing that you will learn in this course is basically problem solving. So any problem that you can think of, you can divide this problem into some logical sequences. That it is any big problem. Say even this mundane daily work. Say you have to go to the market, you have to buy a certain product from a certain shop. So that is also something that you need to think of. You can break that down into some logical steps. For example, you will think that, yeah, no, first I need to think about how I will get to that shop, then how will I pay for that thing, for that object, and how will I return from that shop. So you broke down that problem into three different steps. You can even break it down into further steps. So okay. Okay, so like I said, any problem that you can think of, what I presented to you, just going to the market, buying a thing, that was like a very small problem. So we could easily think of the logical sequences, the steps that goes into that. But if in a similar kind of manner, any complex problem that you can think of can be broken down if you think properly in a logical manner. You can break it down to very small steps, and those steps will directly be used while you are programming or while you are writing a program. So logical thinking, that is what is required the most in this course, and using this logical thinking you will be doing problem solving. Now this problems are the method in which you will be solving the problem is the language, that is C. So C is it's a basically the way that for example I am explaining something to you in English. So it's just a language that I am using to give some information to you. Similarly, this C is a programming language which you will be using to give some information to the computer so that it will be able to solve a problem for you. That is what any programming language is. C is just one of them. Now, okay, so the I skipped kind of a few parts here in the lecture. So next, overall, what Sir covered was what is an algorithm. So, like I said, once you divide it into number of steps, like a complex problem, you have divided it into a number of steps. Now, these steps are basically instructions. If you want, say, a problem that you want the computer to solve, you give them the steps that are to be followed to solve that problem, and those steps basically make up what is called an algorithm. Okay, this is the set of instructions that is required to solve a particular problem. And now as we have as someone among you have already said that there are different methods of explaining algorithm, which are flowcharts and pseudocode. uh, and we covered flowcharts, like the professor covered flowcharts in the lectures as in the week one lectures. So I'll expect you that at least you know a little bit about flowcharts, and we'll solve a few questions on flowcharts, example questions. We'll solve it together. So let's first consider this question. So the question is that what will be the output of the given of the flowchart given below. You can try solving it by yourself, and you can write the answer in the chat box if that is fine with you.
Sir, can we tell by
No, it's better if you write it in the chat box, because if you tell the answer, then it you'll also be informing the others. Probably better not to do that. It's better the chat box doesn't pop up again and again, so it's better that way, I think, at
convert
least.
from chat box also? That's good.
Yeah, but I expect you to solve it by yourself. like we are just starting the course, so it's better if you solve. These are basic things, so you should try your best to solve this by yourself, and we'll also discuss the answers. Okay, so uh, okay, let me. Okay, fine. So uh, let's do one example. I have two more flowcharts for you to solve, so will give more time there. Okay, so the first things that you know that you need to know about the flowcharts are the start and stop symbols. So these are like circular symbols where inside which you can start or stop a flowchart. So start and stop, as you might think, it basically means where the program starts or the program stops, right? Then the next thing is a read numbers x equal to 10. So for input or output, this shape exactly is being used. It's basically kind of a cylinder with spheres mounted, with hemispheres mounted. So it's read number x equal to 10. So basically you are inputting a number that x equal to 10. You are giving this as an input to the computer that x is equal to 10. Some variable x has a value of 10. Now in the next step, you can see rectangular boxes here. So rectangular boxes basically means you are doing some kind of computations. And what is the computation? Y is equal to x. So we have some variable y, and we are saying that the variable of y will have the same value as the variable x. That means whatever was the value of x will be transferred to y. X will also have the same value, but y will also take the value of x. So now that means y will be 10 after this, because x is already 10, so y will be 10. Now in the next step, what we are saying is y is equal to x by y plus 2y. Okay, so now y is 10, and when we calculate this part, what will it be? It will be 1, and when we put x and y values here, it will be 20. So y will be 21. Okay, I hope this calculation is clear to you. Then in the next step, what we do is we print. So this is the output. Um, okay, this was the input. This was computation, like some kind of arithmetic operation we did here. Arithmetic assignment. We'll learn those later on in the upcoming weeks. Um, So and now we have printed y. So the output will be 21, because y has the value of 21 right now after this step. So what it will print is 21, and then it stops. So program execution ends, and our output will be 21. So is that clear to everyone, or do you have any doubts here?
Clear, sir.
Okay. Okay. Fine.
Sir, what is the oblong?
Yes. Oblong, yeah, this one is the oblong shape actually. I forgot the name earlier. So this is the oblong shape. It is used for input or output.
Clear, sir.
Okay. Rectangular shape is used for computation. Circular shape for start, stop, and connector. Okay. Fine. So yeah, this is another question that I have for you. The input n from the user is 7. So there is a step where we are reading some input from the user. So that input is 7 basically. And we are saying, we are asking what is the output of the following algorithm. So can you compute it by yourselves and see what you get? Okay, sorry, I've changed my screen. Yeah, you can see it now again. So So it's quite straightforward. You can you mute yourselves, please? Okay. So let me start solving because we are kind of already halfway into the session. Let me start solving this. So first, we have the start. So we are starting the execution. Now we are reading n from the user. So the user has inputted that n is 7. All right. Now we are setting two variables here. We are setting I is equal to 1, x is equal to 1. So these are the two, we are setting these two variables to be 1 each, and then we are starting some kind of a loop, you can see. But now this arrow that you see, this actually gives the direction of the flow of the program. So we cannot go this way, it is against the flow. We can only go in this direction, like we can go only in this direction for now. So I is equal to 1, x equal to 1. Now we reach, this is what is called kind of a decision box. So it is a rhombus shape. And yeah, does anyone have any doubts? Okay, so this is a rhombus shape where we can write any condition. So all conditionals are mentioned in, like, the shape uses rhombus, and here the conditional is I less than n. So I is 1, so our conditional will basically be 1 less than 7, which is true. Yes, 1 is less than 7, so it goes to the yes part, and I value will increase by 1. So I is equal to I plus 1, means it will be 1 plus 1, that is 2. And then x equal to, x will become x into I. X is 1, so x will be 1 into I, that is 2, that it will be 2. Now after this, you can say this goes back, and the flow of the program goes here, and again it will check this condition. So now I, it will check if I is less than, still less than n. I is 2 right now, so it will check 2 less than 7. Yes, it is. So here it was yes. Here also it is yes. And i's value will again increase by 1, and it will go from 2 to 3. And similarly x value will go from 2 to 6, because it's a multiplication. Then again it will check 3 less than 7. Yes, it is less than 7, so your I value will increase by 1, that will, it will become 4, and x value will become 24. Now again I is equal to 4, so now it will check the conditional again. It is still less than 7, so I value will become 4 plus 1, that is 5. X value will become 24 into 5, that is I think 120. And then again 5, I is 5, so it will check the conditional. It will become 6. X will become 120 into 6, that is 720. And now I value is 6. It will check it is still less than 7. Yes, so I will become 7. Now x will become 720 into 6. I think it's 5040. Now I value is already 7. When it checks 7 less than 7, this is not true. 7 is equal to 7. Like I is no more, it is less than n. So here it will trigger the no, that is, it's a false condition. It's not, this condition is not satisfied. So because this condition is not satisfied, it will go down the no route, and it will print x. And what is x here? So you're basically printing 5040. So the answer here will be 5040, and then we stop the code. So is this clear to everyone? So this actually, this entire structure, as we will come to know later on in the upcoming weeks, I guess, I think week 3 or something, or week 2 maybe. So it is called a looping construct, or simply a loop. There can be multiple types of loops. We'll be visiting them whenever it is taught in the lectures. Okay, so as in, does anyone have any doubts here in this particular question? So you want me to repeat this, or like I couldn't get actually. What do you mean by teach one more? Yeah, for those who wrote 720, did you understand where did you go wrong? Okay, I'll just briefly explain it again. So initially you had this value of n, which is 7, and I and x were set to 1, and now we check first that is I less than n. So this basically means it's a conditional. We are asking that if I is less than n, then it will execute this yes part. If I is not less than n, it will go to the no part. Now initially I is equal to 1, n is equal to 7, so it is definitely 1 is less than 7, so this is satisfied. So this condition is satisfied, and it will go down the yes route. So if it goes down the yes route, what will happen? I's value will increase by 1. See, I is equal to I plus 1. So basically, I'm writing I, that is 1, and plus 1. That means it will become 2. The value will increase by 1. And the value of x will multiply by I. That is, initially the value of x is 1, and it will multiply by I. I is 2 here. So the value of x will be 2. Now this will come back again to this point, and at this point you can see the arrow is pointing towards this direction. So we will again reach the conditional here, and it will ask if 2 is less than n, because I is now 2 and n is 7. So it will ask, is 2 less than 7? Yes, it is less than 7. So again it will come here, i's value will increase to 3, and x value will increase from 2 2 to 6, because you see x equal to x into i's value is 3, and x itself it was 2 earlier. So 2 into 3, it will become 6, and then again it will go again it will go back here, and it will check this conditional. So that will go on until it reaches a point where 6 is less than 7, the conditional is satisfied. So it will come here, i's value becomes 7 now, and x value becomes 5040. And after that, when it goes back here at this point, i's value is 7 at this point, I is 7 and n is 7. Now if you say I is less than 7, that is false, right? It is not true, because now both are equal. It's not less. I is not less than n. So it is a false condition. Now because it's a false condition, it will go down the no path, and it will go and print x. Okay, and x has the value of 5040, so it will print 5040. I hope that is now this more clear.
Excuse me, sir.
Yeah.
Sir, in that case, that when I becomes 7, then according to the loop, previously x got value 720, then the new value of I is 7, when 6
Okay.
is less than 7. So x should be multiplied by 720 into 7. Then
Okay. Yeah.
that
Yeah.
could,
Yeah. Yeah. Right.
then,
Yeah. This should be 7. Sorry. Yeah.
so there is, so the answers given are incorrect in the MCQ.
No.
There is
No.
no the correct answer.
No. It's correct, right? It's 5040.
Yes,
I
sir,
just.
correct, correct,
Yeah.
correct, sir.
Yeah. Sorry. I wrote 6 by mistake here. No, it's 7. Sorry. So it will multiply by I basically. So I is 7 here. So it will be 720 into 7. That will be 5040. Okay. Thanks for the correction. Okay. So if anyone doesn't have any more
You're
doubts,
welcome.
if anyone doesn't have any more doubts here, so this is, I guess
No, sir, you can continue.
you might have
Clear,
been
sir,
familiar with factorial, the concept of factorial. So this is basically the code for a factorial. Like if you have to compute the factorial of a number, this is what you have to do. So, okay. I have another flowchart for you, because that's the most technical part that was covered this in week one's lectures. So let's try to solve this. So what it says is x is an integer. Its value is 1248, and the print value of y in the flowchart below is. So it is asking what is the print value of y, and x, as you can see, is it has a value of 1248. So please try solving this. And here, if you're not familiar with this particular function, so basically if you say 1248 percentage 10, it is called the remainder function. Yeah, the remainder function, and it will give you basically 8 here, because it will divide 1248 by 10, and whatever is the remainder, it will give you that. I think it is AIN, remainder function. Yeah. So this will basically give you an 8, because it will, when you divide it, it will be 124, then 8 will be left. So 8 will be your remainder. So keeping that in mind, can you try to solve this particular flowchart and tell me the answer? So you can write the answer in the chat box. Okay. Okay, I'll just allow a little bit more time for you guys to solve this. This is also kind of a looping mechanism, but the loop checking, as you can see, is occurring at the end of the iteration. In the earlier one, if you had seen, the loop checking, the conditional was somewhere around here, like it was I is equal to 1, x equal to 1, then we had this conditional here, but here the conditional is at the end. So this is a different kind of a looping statement than the one that we encountered before. So when we cover looping statements, we'll be covering this. This is quite interesting. The way this works is kind of a little bit different from the one that occurs before, that we visited before. Okay, so now you can just try to solve this. So first, when you see this, when the program is started, we read x. When we read x, we have given the value x is equal to 1248, and in the next step we set y is equal to 0. In this particular statement, we set y is equal to 0, and then our looping construct, it starts. So the first step is y is equal to y into 10 plus x percentage 10. Okay, so now what exactly is this? So what it will do, 0 into 10 plus x percentage 10. Like I said, if you do x percentage like 1248 percentage 10, you will get 8. So basically y is 8 now, and then
Sir, I have written the answer which I put. Would it be 1?
yeah, I have to check actually. 1, I don't think so. I don't think it will be 1. Let us solve this, and hopefully we'll see.
Because it will go on decreasing. That's
It's okay. Let's see if I can answer this properly. Okay, let's see. Let's solve this, and then we will know the answer. I also am not sure which the answer is. I'll also have to solve this and check. So say y is equal to 8, that we have found out, and then we are saying that x is x by 10. So x from 1248, when we do 1248 by 10, so here we will just discard the decimal part, because we are not really defining what kind of okay, it's an integer we have said. So yeah, okay, so it is an integer we have said, so it will definitely not have the decimal point value. So this 0.8 here, it will be simply discarded, so it will be 124. Now if is x is equal to 0? No, it is not equal to 0. So this is not satisfied. No, it's not satisfied yet. So we'll go again to the through the no route, and it will return back here. So what happens here? So we are saying that y is equal to, now y directly I'll write the values here. So just look at it carefully. So y into 10. So y was 8. So I put 8 here into 10 plus x in x percentage 10. So x was 124, and I am writing percentage 10. That means this will come to 4, because like I said, the remainder function here, the quotient will be 12 and the remainder will be 4. So 80 plus 4. So basically it is 84. Okay. Now sorry, now it will check, is 84 is equal to 0. No, it's still not 0. So it will come here again, and we'll repeat the same thing. Now y is already 84, so it will be 84 into 10 plus okay, sorry, I missed the x part here. So x is equal to x by 10. Now x is how much? 124, so it will become 12. Is that clear? Can you see this particular part? uh, Otherwise I'll just write this down here. X is equal to x by 10. That means it's 124 by 10. It will be 12. Was it's an integer, it will be 12.4, and the decimal part, the part after the decimal, will be ignored, and it will have a value of 12. So now in the next step, it will check, instead of this, it will check, is 12 equal to 0? No, it is not equal to 0. So it will come back, this will come back here. Y is equal to, now it will again recalculate, y was 84. It will be 84 into 10 plus x was 12. So 12 percentage 10, that will be 840 plus 2, that will be 842. Okay. Now after this, again x is equal to x by 10. So that means x was 12 here, so we'll have 12 by 10. Basically we'll have 1, because this is basically the quotient part. All right. And x is still, 1 is still not equal to 0. So this will still be no, and it will go back here. Again we have to recalculate this. Y is equal to y into 10. So y was 842 into 10. Now x is 1. 1 percentage 10. Now 1 percentage 10 is 1 percentage 10 is actually 1, because if you divide 1 by 10, like if you divide 1 by 10, like the remainder itself should be 1, because it's not divisible. It's 0 is the quotient, and 1 is the remainder, so it will be 1. So 8420 plus 1, so 8421 will be y. And now if you calculate x, it will be 1 by 10. So basically 0.1 if you convert to an integer, it's an, if you take the integer part, the part before the decimal, then it will simply be 0. And is 0 equal to 0, x equal to 0? Yes, it is equal to 0 now. So it will go to the yes root, and it will print y. So y, the value of y will be 848421. Is that clear now? So
Yes, sir.
yeah. Okay. Any more doubts from this particular flowchart? Okay. I am expecting then we'll move forward. Okay. So again, a bit of theory here and there. So different components of a computer. I'm pretty sure all of you know this. We have input devices like we have keyboard and mouse, and this joystick and so on, and the input devices send the data to the central processing unit, which is composed of ALU and CU. There is the control unit, which handles the operating system, and the ALU, which does all the calculations, mathematical operations, logical operations, and so on. And it will exchange data with the main or internal memory, mostly the RAM, and there are many CPU registers and so on here, which will be handling all the temporary memory basically, and for multiple steps. and then finally the output, when the output has been calculated, it will send the data to the output devices, which can be a monitor, printer, and so on. I hope that's more or less clear to all of you. Okay, fine. So next is number systems. So this is something I just wanted to give a brief intro about. So you might be familiar with decimal number system. It is a system of base 10. So for any number system, we need a base value. So what exactly is the base value? Is that we will have the numbers less than the base value. Like if we take a base of 10, we will have numbers 0, 1, 2, 3, 4 up till 9. So you have 10 numbers which form actually this 10 numbers form the basis of the decimal number system. Using this 10 numbers, uh, you can express any higher decimal number using this 10 numbers. Okay, so that is why it is a system of base 10. So 10 different numbers can be used in order to in order to express any higher decimal numbers. Okay, similarly, this is the one that we usually use. It is kind of the high level understanding that we have is of the decimal number system. Now if you think about the binary number system, so what about the binary number system? This is something that the machine understands. It's the machine level number system. So the machine uses the binary number system, which has a base 2. That means it has only the two digits 0 and 1. Now whatever you enter to the system, it will be converted to the form of 0 and 1, and it will be like only then the system will be able to process that. So this is a system. This is a binary system which is used by the computers. So now I have a question for you, that you have to convert a certain binary number. So this is a binary number, you can say, because I have given a base 2 here. So the representation here, you can see 1011.101 and in bracket, and I have given a subscript here which is 2. That means it has a number system of 2s. That means this particular number that I have written is of base 2. And you can now try to convert this to decimal. So if you want to convert this to decimal, is anyone familiar how to convert this to decimal? A binary number, how to convert it to decimal? Is anyone familiar? You can just unmute and tell me. Okay, in any case, let me just refresh your memory. I guess you might have learned this, but you might have forgotten. So let me just jog your memory here. So when we have a decimal number here, let me write it with a little more gap, the way I want to represent it. Okay, so this is basically the number that we have in binary. Now what you have to do, this is the decimal point here. Start before the decimal point, write to the power 0 below this, and keep on increasing the powers of 2. Okay, similarly, after the decimal point, go to negative powers of 2. All right, now multiply this with this with this with this with this with this, multiply and add all of them. Now what you would get here? So
Sir, 93.
yeah, so something, I think it would be around that. So uh, basically
93.
793. That's what you're saying, right? This, but there should be a decimal. There should be a decimal part here. How come it will be a? I don't think it will just be an integer. There should be a decimal part. Anyway, we'll see. So 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0.
Sir, it would be
Yes.
13.875.
13.875. Okay. Okay. Okay, fine. We can probably calculate that. I'll just write down the procedure for you. Maybe you can calculate and check how much it is. Okay, so 1 into 10 to the 2 to the power minus 1, so basically 1 by 2, and 0 into 1 by 4, and 1 into 1 by 8, right? So if you add all of this up, I guess it will be this will be 8, this will be 2, this will be 1, so I guess 11 here, and half point 4. Okay, yeah, this is 8, this is 2, so 10, 10 plus 1, 11, 11, so point 5 here, and point 125 here, so point, so 11.625, like, maybe. Is my calculation correct? I'm not sure. Just check it out if this is correct. But
Sir, 1 by 2 would be 0.5, 1 by 4 would be 0.25,
no, no, this is
0.7.
multiplied with 0, so this will not exist. This will not exist. Only this and this will exist because you are multiplying with 1. Similarly, this will also not exist. So you have 8 from here, you have 2 from here, you have 1 from here. So that makes 8 plus 2 10 plus 1 11. And now you have point 0.5 from here and 0.125 from here. So 0.625 from here. So 11.625. Is that, am I correct? Basically the procedure will be
Yes,
this
sir.
same though. Okay, so the procedure, I hope you can understand the procedure. So we are basically multiplying all of this as the way I have written here, and anything multiplied with 0 will be 0, so only the ones you need to consider when you are multiplying, only the corresponding values of 1, that is what you need to consider. Okay, so now this was the binary number system. There could be other and we have the decimal number system also. But we could have different number systems. Actually, we can define a number system of any base if we want. We can have a base 3 number system. It will have the digits 0, 1 and 2. You can have a base 4 number system, which will have the digits 0, 1, 2, 3. Okay. So similar to that, we have defined octadecimal and hexadecimal number systems. As to why this particular base is selected, it's something to do with the memory. When we go
Sir,
for,
that should be octal. Octadecimal would mean 8 plus 10, 18. That should be octal.
no, no, it's not like that. It's just the name that has been given as octadecimal, but it's a base 8 system. Okay, it's not that it's not a improvement
Sir,
over
like
decimal.
sir,
Yeah,
like hexadecimal,
yeah, I
10.6 and the 6.
okay, okay.
That's
This,
the
let's say it is octal number system. Is that okay? Yeah, it is also called
yes,
octal
sir.
number system. Okay. So if we call it, say it's octal number system. So octal number system is a base 8, and hexadecimal is a base 16. So why this higher base systems have been defined, especially the hexadecimal system, because you can represent very large numbers in very short form. Like for example, if you calculate this, you will know how big a number this is. Like that we have just represented in this very short form. It is actually, it will, when you convert it, it will be converted into a very large number. And how to do that is simple. So in hexadecimal number system, you have 0 to 9 and then a b c d e f, and this a represents 10, b represents 11, c represents 12, d represents 13, e represents 14, and f represents 15. So similar to what you have done here, to convert it to a decimal, what you have to do is you have to start from this side. Let's again write that down, and we'll write 16 to the power 0 here, 16 to the power 1 here, 16 to the power 2 here, 16 to the power 3 here, and we'll multiply this and we will add them up, all of this. So it's basically 6 into 16 to the power 3, and a, what is a? A is 10. So 10 into 16 to the power 2, then we have 7. So 7 into 16 to the power 1, and we have f. So f is 15. So 15 into 16 to the power 0. So you can calculate this. So this will be the decimal
Yes, sir. 27263, sir.
27263. Okay. So it should come around this number. So you can see like this is a bigger number and we have represented it in a much smaller form. If say there can be numbers, say if I write simply 5 A's, this is still a hexadecimal number. Okay, this will be a hexadecimal number and its value will be quite large. So you can represent a much larger number in a much shorter format if you use the hexadecimal number system. So that is why these higher number systems have been developed. And as for the octal number system, the number system itself is based on something which we learn in the storage. We say that if you remember, 1 byte is equal to 8 bits, and it has something to do with the memory. You can see there is some similarity here, like the octal number system has a base of 8, and also whenever the storage is counted, it is counted in terms of bits or bytes, or or bytes. So this octal number system, basically it was defined initially from the storage perspective, like how a number would be particularly stored. But this hexadecimal system was defined so
Sir,
that just a minute, so that larger numbers could be represented in more shorter forms. Okay, yeah.
sir,
uh,
I was saying it stands for binary digits and bytes. What's the full form?
uh, can you come again? I couldn't actually get your question.
Sir, I was saying bits means binary digits. BI for binary and TI from digit last. So bytes has been taken from these two words.
No, no, it's not like that. It's basically, uh, if you consider a 0 or a 1 in the binary number system, this is basically one bit, one bit that you're talking about. Like whenever a particular number, say you have a number in, okay, let's say this particular number. Now every 0 or every 1 here requires 1 bit for storage. That's the definition of a bit. It's the smallest memory storage, basically. Okay. I couldn't get your question exactly, but I hope this is what you're asking, like if there is any
Sir,
relation.
I was asking what is the full form of bytes, what it stands
What it stands for? Okay, there is no full form as such, but like it's a terminology basically on the
for. Sir, like Anupam sir told that bits stand for binary digits, so we can easily remember and understand such like
okay.
a concept.
No,
So
no,
how
it's
can we learn the bytes?
uh, no, I am not sure. I don't know any full form of byte as such. But yeah, this is basically the most common relation. You might have seen everything is most more or less written in bytes rather than in bits, and this is the relation between bits and bytes. That's all I can say, because I'm not sure if there is any full form to byte as it is. It's just a terminology that was coined, and on top of this, there were like you have megabytes, and gigabytes, and so on. On top of this, like just the higher denominations of byte. But I'm not sure if there is any full form to this.
So before that would come kilobytes, and after gigabytes would come petabytes.
Yes, After, that is okay. That is okay. That I got it. But uh, I'm not sure if there is any full form of byte
Sir,
as it is.
I searched the Google and I found that its full form is the binary element strings.
Okay.
Binary is DY, element is ES, binary element DY it means
Okay, but knowing that wouldn't really help, right? What did you know by knowing that it's a binary
Sir,
element string?
it tells me that it is a string or collection of binary digits, like one byte contains 8 bits, so it is a collection of
Yeah, okay,
binary digits.
but at the end,
So in this way, it will calculate.
okay, fine. But at the end of the day, you still had to remember that 1 byte is 8 bits, right?
Yes, sir.
Yeah. So what exactly does it give you more than that?
And more than that, I can visualize the concept. So I am not a fan of that.
So
like
basically here, one byte has this storage where it is divided into this 8 sections. I guess I divided into 8, yeah. And every section is, here it is 1 bit, here it is 1 bit, and this entire thing together it is considered as a byte. This is what you are looking for, right? This kind of a
yes,
visualization.
yes, sir, like that, and it would mean like 16 zeros and ones in pairs, like 2 to 8.
Okay. Wait. If it is, yeah, it. I couldn't get what you tried to say just now.
Then I was saying to stone one would include 0 and 1, a
Yeah.
pair of 0 and 1. So
So
it would include 8 pair of 0 and 1, and if we separately look at, so 8081 or total 16 digits.
nothing, not like that. So it's there can be many combinations here. Okay, it's not.
So with zeros and ones.
Yeah, not.
But I'm not talking about combination. I'm only saying about if we look in common individually, then it would be 16 zeros and 1 in total, 8 zeros and 8 1. The sum of that 16,
Yeah, like
the zeros are common too.
every bit can have either 0 or 1 stored there. Okay, basically
Yes,
that's what is the concept, that one. uh, can can you please mute? It's, I think, lots of background noise coming in. Okay.
Good evening, sir. Actually, I
Yeah.
have one question.
Yes.
Actually, in computers, everything is in binary. So, what is the need of using octal and hexadecimal? At the end of the day, everything is converted into decimal,
Yes,
right?
but it makes it easier for us to visualize numbers. After a certain point, you will see that if you write decimal numbers they end up being very huge. Like for example, uh, there are set limits that you can define. Probably we'll cover that in upcoming weeks. Every data type, or although yeah, data type. Okay, fine. So there is, like, if you want to express an integer, then there is a set limit up till which you can express an integer in any
Okay.
programming language. So if you use a
Oh,
hexadecimal system, you can actually express a longer or a larger integer set without actually having to, like, yeah, you can say that yes, I can write the entire number there. Still, I can do that. Yes, I can do that still, but it just makes things simpler for us if a 10 digit number can be reduced to, say, a 5 digit number. All right, like there, just the expression part, finally it is going to be converted to binary anyway. No
okay.
matter what you write, it will be converted to binary. It's just for the convenience of the programmers. Like, that is what
Oh,
I'll be talking here also. So earlier, okay, in programming languages there are three different levels. Machine level, that is binary code basically. This is binary, and we this is the current level that we use. This is a high level code that we will write the programs in high level. But there is also a assembly level. Okay, assembly level had a lot of features from both machine level and the high level. So basically it was a combination of the machine level and high level features. But eventually it did not become as popular as the high level language. Why is that? Because there were a lot of things which you had to write in on the machine level, and that was not very convenient for people. So what they did is
yeah.
they shifted more towards high level language, which we are using right now. All of this C, C++, Python, Java, all of these are high level languages because it is just for our own convenience. So most of the all of these things should has to be handled by this compiler or interpreter. We will allow all them to handle the hard work. We'll just write it in the easiest form that we can. So that is what is the mindset currently.
Okay.
Okay.
Thanks.
So hexadecimal is basically the same kind of thing. Okay, so here what I was saying is there are three different kinds of languages: machine level, assembly level, and high level. So high level is basically the language that we will be using to write the code. When we write, say, okay, till now we haven't been introduced to int, but I'll just write it down for example here. We'll see what int basically is. So this is a high level statement. We are saying that there is some variable which is 5, and this statement will be converted from high level to the machine level through a compiler. Like for C, it is a compiler. For other languages, it might be interpreter. For example, Python uses interpreter. C uses a compiler. C++ uses a compiler. So it varies from like device to device and language. Sorry, not device to device, language to language. So these are the three different levels of language, and uh, we'll be using C is a high level language. Sometimes C is called a middle level language also. So you might have heard this that C is a middle level language. What there is nothing called a middle level language. The only reason why C is called a middle level language because you can write both application software using it and system software. So you can write both application and system software using C. Only because of that, it is called a middle level language because it can interact. It can you can use it to write system software which interacts with the system directly. Okay, and application software which interacts with the with the system software, not directly with the system. So it can be used for high level applications as well as machine level applications. That is why it is called a middle level language. But in if you say it from a very technical, very strictly technical point of view, it is a high level language. Okay. Okay. So yeah, it's just again we are going back. Okay, we have been discussing theory here, and this
Sir,
statement.
what is assembly level language?
Assembly level language is okay. It's kind of a combination of like it has some features of machine level language and some features of high level language. Like you will both be writing in terms of binary as well as high level like source code kind of writing. So it will be a combination of the both, but it's not really that popular anymore because it was very difficult when you had to write it from a binary perspective. Okay, so it's not really that popular anymore, but you can directly interact with the machine using this assembly level language. Okay, but nowadays most of it is high level language that you will be currently in this course at least you will be using only high level language, that is C. Okay, okay, fine. So,
Sir,
Sir,
so for
yes,
what purpose assembly level language is used?
assembly level languages. I think it is being used in when you're writing microprocessors like softwares for microprocessors and so on. I think you use assembly level language because there is some level of involvement, machine level involvement there. So you'll be using assembly level language for such kind of applications. Okay.
sir, actually, we are having compiler for C, right?
Yeah, we
So
have
is it
compiler.
possible to build an interpreter for C? Is it actually available for
Uh,
programming?
I'm not sure if it is available. It is definitely possible to do that. Uh, okay, but the interface itself you have to change because uh, okay, so whenever you have, yeah, you can write an interpreter, but I'm not sure if there are any available interpreters for C at this point. But it is possible to write an interpreter or compiler for any programming language. Okay, is that
Okay.
probably interpreter would be more complex in case of C? I don't know exactly. Okay,
Okay.
so you
Okay, sir.
require.
Sir,
Actually, I'm.
so what would be better, interpreter or compiler for C?
Uh, as far as I know, compilers are used in C, so I wouldn't say one would be better than the other. It's just that interpreter will give you an error immediately. Like say, interpreter they check the error line by line, so they will give you once you finish that line and go to the next, they will show that there is an error in this line. So for some people that is better, like you get to know that this is an error immediately as soon as you have written it. For some people, after like if you use compilers, you write the entire program and then you compile it and know that there is a error, syntax error or whatever error on this particular line. So if you see from that perspective, probably interpreter would be more preferable because it gives you the error immediately whenever you have one. But there can be some exceptional cases as well. Okay, so it's basically, to answer your question, it's not really one is better than the others. Both are used in different programming languages differently. Like some applications have compilers, some have interpreters. That's
Okay, sir. Thank you.
all.
Cleared my doubt.
Okay.
Sir, actually,
Yeah.
I know some compilers like Turbo C and GCC. What are the available compilers for C? In industry standard, what they are using to develop?
I think the GCC compiler is what is because it's being used in all Linux systems. So I think GCC would be the compiler that is being like that is updated as well. So yeah, that is currently if you are looking for a up-to-date compiler, GCC would be the one. Turbo C it is very outdated at this point.
Yeah, yeah, yeah. Okay. Is it possible to run compile program on one compiler in another one? Like, see, if I have compiled my code in GCC, is it possible to run the same thing on Turbo C?
Okay. No, every compiler has its like you would say um, like the way finally the version of the code it generates after like the machine readable version, it can differ from compiler to compiler. So you should always use the compiler that came with the package of the execution. Like it comes as a integrated development package, right? Environment, right? So you should
Yeah,
always use the compiler that they have given, because the final machine readable out the .out file, it might be in a certain format that is specific to that like to that execution thing, right? It may not be like there is a possibility it may not be the like it may not be this it may not be different also in some cases. For example, say in say you are using Ubuntu, okay? You are using
yeah,
Ubuntu and
mm,
you compiled a file using GCC, that is the default compiler which is already available in Ubuntu,
mm.
and you get a .out file, and you can use that in a different Ubuntu system as well, like which has the same GCC version. Okay.
Okay, okay.
Okay.
Mm.
You can directly use that .out file in a different computer with the same GCC version. Because even among versions also, there might be some changes that have been done which will change your .out file. But if it is the same version, then you will be able to run that in a different computer with the same GCC. Okay.
Okay,
Uh,
sir. But it may not be work with the GCC or some other compilers available.
it may not work with Turbo C. Yeah, like
Okay, okay,
it
okay.
is
Thank you.
entirely possible.
Thank
Yeah.
you. Okay, sir. Thank you.
Okay, so the last thing that I wanted to cover here is what exactly is a variable. A variable is basically a memory location in the RAM, which is basically the main memory that we talked about in that earlier figure. And what does x equal to y mean? When you are saying in the previous one of the flowcharts, we saw x equal to y. That means in say this entire thing is this RAM, just a rough representation. Just say this is the RAM, and we have a variable called x. So this is some memory location in the RAM, which is basically which we are calling as x. Like whatever value it stores a particular value which pertains to the value of x. And similarly there is another memory location which is allotted to variable y. Now when you say x is equal to y, what will happen? uh, the uh, the value of y, the value that is present in this memory location, will get copied to this memory location. So x is equal to y, that means x will take the value of y. That means the value of y that is stored, say here the value was 15, it was stored. Now this 15, this value of 15 will be copied to the memory location of x, or variable x. So x will also now become 15. Okay. So this is basically what happens when we write x equal to y. Similarly, if you have if you write x equal to y into z, say y and z are some memory locations here, and you have another memory location x that you are defining, and y and z, say this has a value of 5, this has a value of 2. Now what will be done is this value of 5 will be taken, this value of 2 will be taken, it will be passed to the ALU, it will be passed from the main memory like we saw in that previous okay, yeah, here from the internal, it will be somewhere here in the internal memory, and it will go to the ALU, and the ALU will calculate this 5 into 2, like 5 times 2, it will just calculate that, and it will send the information back into the main memory, and it will store this final information, which is basically 10. It will store that in the in the memory location of variable x. So this is the entire operation that occurs, and inside the ALU itself, like I'm talking about it, the 5 and 2 value exactly will not go. It's basically the binary forms of 5 and 2 will go, because there is a step I have skipped here. It is once you have compiled this code, all of this 5, 2 and everything, it will be converted to their binary forms. So the binary values will go to the ALU, which will calculate, which will do a binary multiplication, and then that binary value will come back to the main memory and be stored in the memory location of the variable x. Okay, so this is basically what happens when we write y is equal to x is equal to y into z. So I hope all of this is clear to you.
Yes, sir. Clear.
Okay. Okay. So I guess that was all for today. I had one more question. Just if you can answer this, it is a bit more complicated than the others. So, but we partly discussed this. It is basically to draw a flowchart for extracting all digits from a natural number. Say n. N can be anything. Say you can take a say n is equal to 1, 2, 3, 4. Say it is a user input. Okay, and uh, just draw a flowchart to extract all the digits. That is, you have to print each of the digits 1, 2, 3 and 4 from just by taking this. So try to figure this out. It has something to do with n percentage 10, as that is the way to extract the digit. You can extract the last digit using this n percentage 10, and somehow you will do some operations and uh, to reduce this number to get it. So try to think of the solution yourself. We'll probably, if we have time, we'll discuss this in the next class. But I think you should be able to.
Sir, can you repeat the question?
Yeah,
Can you repeat the question, sir?
the, the, the question is just there is a number n which is say 1, 2, 3, 4. Okay, so 1243, and you have to extract each of the digits from this number. So you will print 1 separately, 2 separately, 3 and 4 all separately you have to print. So you have to extract all the digits from the number, which is the user input is 1, 1, 2, 3, 4. Okay, so you have to write a flowchart for doing this, for extracting all the digits from this number. Okay, with this we have come to the end of today's class. So we'll be meeting again next week, same time, uh, 6 to 7 Tuesday. So yeah, thank you all for attending.